Today's lesson is Applications of the Pythagorean Theorem, Day 1. So recall from the previous lesson that we used the converse of the Pythagorean Theorem to help us find out if a triangle is truly a right triangle. So basically what that means is that when you take the squares of two sides of a right triangle and you add them together, they should be equal to the square of the length of the third side if it's truly a right triangle. So that's what we're going to do as our warm-up today. I want you to review what we did in the previous lesson. Do the following sides form a right triangle. Prove your answer using the Pythagorean theorem. So that's a squared plus b squared equals c squared. So you'll look at the group of sides, decide which one should be the hypotenuse based on what we discussed previously, then plug those values in to see if it checks in order to figure out if this is a right triangle or not. So please pause the video, try warm-up exercises with the first group and the second group, then resume the video to go over your answers. All right, since you had a chance to try, in the first group, I highlighted the hypotenuse. The hypotenuse, if you recall from the previous lesson, is the longest side. So 15 is the largest number in this list of 3, so 15 has to be the hypotenuse. It doesn't matter if 12 is A or B or if 9 is A or B. So I did 9 squared plus 12 squared equals 15 squared, which would be 81 plus 144 equals 225, which means 225 does equal 225. Since it checks in the Pythagorean theorem, that tells me that the sides here are making a right triangle. In the second group, the longest side is the hypotenuse. So in this group, the largest number is 11. So 11 should be the hypotenuse. That means 4 and square root 6 are the lengths of the legs. 4 squared is 16. When you take the square root of 6, but then turn right around and square it, you end up with the same number that was underneath originally, just 6. And then 11 squared is 121. 16 plus 6 makes 22. 22 does not equal 121. So that means no, these do not make a right triangle. So we start there because it's something you're familiar with, plugging in numbers and checking. Except that we're doing it with this Pythagorean theorem formula. So when things do check, it's telling us that those sides make a right triangle. When then those sides don't check, it's telling us that those sides do not make a right triangle. So today we want to discuss what else can the Pythagorean theorem find for us. So we're going to go through a few different examples of ways the Pythagorean theorem are used differently than the converse and just finding the hypotenuse like we did yesterday. I am going to start with what we did yesterday, which is using the Pythagorean theorem to find the hypotenuse. So you did this in the previous lesson. We'll review it before we find out 2 additional things that we can also do. So today we also want to concentrate on the difference between exact and approximate answers again, so make sure we're always reading the directions. This says, write and solve an equation that will allow you to determine the length of the unknown side of the right triangle. It states that they want us to provide an exact and approximate answer, and we should be doing our approximate answer rounded to the nearest tenth. So in my picture, across from the right angle, remember the longest side is the hypotenuse, and that's the side we do not know. So one of my legs is 3, and one of my legs is 9, so they will be our A and B values. So we have A squared plus B squared equals C squared. A is 3, B is 9, and C we don't know. Now, normally when we do substitution, you can put parentheses around the numbers like that. Since these are positive, they're not necessarily needed, but you know certain values you're going to want to use those parentheses. So 3 squared is 9. 9 squared is 81. And then we get C squared still on the other side. 9 plus 81 is going to give us 90. And then that's C squared. I don't want C squared, so we're going to take the opposite of squaring something is taking the square root. So we'll take the square root to get C, and whatever I do to one side, I'll do to the other. Now, before I write my answers, remember we're doing this 2 different ways. We're going to do an exact answer. Exact means no decimal values, nothing with rounding. So we're going to leave it as a square root. So square root 90 centimeters is the length of the hypotenuse if we're asking for an exact answer. For approximate, This is where we're going to type the square root of 90 right in our calculator. And I'm going to write down the long, ugly decimal that I see first, which is 9.486832981. And it keeps going. That is an irrational number. It's a decimal that goes on forever and doesn't repeat. So now they wanted us to round this to the nearest tenth. So I'm going to look at the hundredths place. That number is 5 or bigger, so that means we're going to bump that 4 up to a 5. So this should be approximately 9.5 centimeters. So that's a review of what we've already done in the previous lesson, which is find the hypotenuse. Now we can also use the Pythagorean theorem to find a leg. It's not only the hypotenuse that might be missing. So in example 2, write and solve an equation that will allow you to determine the approximate length of the unknown side of the triangle. We're going to round to the nearest tenth of a centimeter. So this one only wants the approximate length, and we're rounding to the nearest tenth. So this is a right triangle. Across from that right angle, the longest side will be the hypotenuse. You can see one of our legs is already labeled as A, so that means 4.2 will be labeled as B for our other leg. So we'll write A squared plus B squared equals C squared. In for A will go nothing because we don't know what it is. In for B is 4.2 squared. And then on the other side, in for C will be 8.5 squared. So A squared stays A squared. 4.2 squared, you'll type in your calculator, and you get plus 17.64. And then 8.5 squared, you get 72.25. Now, here's where it's different than finding the hypotenuse. When we're finding the hypotenuse, we're not solving by adding or subtracting anything from each side. When you're finding a leg, you have to do that. So we're trying to find the value of A. What is hanging out on the same side as the A's that we don't want to be there anymore? It's that 17.64. So there's an added step when you're finding a leg. We need to get rid of that 17.64 by subtracting it. Whatever I do to one side, I have to do to the other. So I get A squared equals, when I subtract those two numbers, I get 54.61. Now we have A squared equals 54.61. So to undo squaring something, we take the square root. Whatever we do to one side, we do to the other. So we end up first with the long decimal of A equals 7.389857915, and we know it's going to go on forever. This is an irrational number currently, so we are asked for the approximate length to the nearest tenth. So once again, look at what comes in the hundredths place. That 8 is 5 or higher, so it wants us to push that 3 up to a 4, which means A is approximately 7.4 centimeters long. Okay, so just make sure you're paying attention to whether you're solving for the hypotenuse or the leg. If it's a leg, you are going to have to subtract a number away first before you can take the square root. Now, lastly, what else can Pythagorean theorem find? So Pythagorean theorem can also find parts of another triangle. So in example 3, we have an isosceles triangle, which means two sides are equal. If you look at the picture, you see two sides labeled as 10 inches. It's shown below with sides that have a length of 10 inches and a base with a length of 12 inches. What we're looking to find here is the area of this triangle. So let's think about this for a second before we even continue. Area of a triangle is A equals 1/2 base times height. So in order to find the area, I need the base and I need the height. And currently, the only thing that I have that will help me with this is they told me the base. I have no idea what the height is. So I'm going to need to have to find that height before I can find the area that I'm asked to find. So I've walked you through with these steps kind of to think of on the side. First, we need to see where the height even is. So we're going to draw a line from the vertex, which is this top point here of the triangle, down perpendicular to the base. Perpendicular means it's going to be sticking straight up from that base, which is going to create a special angle of 90 degrees. So we're going to put a little 90-degree mark there, showing that. And it says, draw in the right angle, which we did, and then label with H. So just to show you how that's going to help us, because sometimes with the bigger picture around it, it's a little confusing. We're going to draw just one portion of this triangle now. We're going to draw a right triangle to the right here that represents half of this original isosceles triangle and label that height as H. So I'm basically just going to copy the right-hand side. I'm going to make my line for H. And then we're going to come down here to make the bottom. And then here to connect to make our right triangle. I'm just drawing a sketch of the 1/2 of our original isosceles triangle. Now, we don't know the height, so that's H. This diagonal is the same as it was originally, which is 10 inches, but we have to figure out what this portion right here that I'm marking in purple is. Well, that perpendicular line dropped down and cut our isosceles triangle in half. So if all the way from here to here was 12, this would mean that from the middle where we dropped down the line for H to the end would be 6 inches. So this here would be a 6. So now we have what we need. We have 2 out of the 3 sides of a right triangle, which means we can use Pythagorean theorem to find that missing height. So a squared plus b squared equals c squared. When we look what's across from the right angle, 10 is the hypotenuse, so that goes in for C. H is one of the legs, so we'll put that here, and 6 is the other leg, we'll put that in for B. So we end up with h squared plus 6 squared is 36, equals 10 squared, which is 100. This is another example like we did above. A leg is missing, so we can't take the square root yet. We have to get h squared alone by subtracting 36. And so h squared equals 64. Now to undo h squared, we will take the square root of both sides, which means h equals 8 inches. Our height is now 8. So when it says find the area of the original isosceles triangle, we know we're going to use A equals 1/2 base times height. We now know that's 1/2. The base is 12 because it said the original. So let's really make a point of that. We want the original isosceles triangle here, not the little right triangle. We only use that to find the height. So the base is 12, and now we know that the height is 8 from our work with Pythagorean theorem. So that means we have 1/2 of 12, which is 6 times 8, which is 48. So the area of this original isosceles triangle is 48 inches squared because it's an area. And that concludes our lesson on applications of the Pythagorean theorem, day 1.